Alright, I'm going to talk about the worksheet, the stuff on the worksheets that I gave you last week, just in case you needed help with that. So it's the projectile motion problems. There were two different worksheets. One was a full page. The other one was I accidentally put four problems when you really have to do two. It's the same problems are repeated. So you have 5 homework problems really, and so I'm going to try to go over what you need to know to be able to do them. Alright, and so it's basically four quantities. One of them is a constant. VI is the initial velocity. Let me zoom in a little bit. VI is the initial velocity. Okay, and this is the formula you can use to find that. X is how far it travels horizontally, and so let me get my... This is X right here. This distance right here. So from the point it is shot, or kicked in this picture's case, to the point at which it lands. Okay, and then the angle of elevation is the theta that you see over here, and that is this angle right here. Alright. You don't even need to necessarily understand that, although I prefer it. You don't really even need to understand that to be able to do that activity. Right? As long as you can figure out what the word problem is saying and what's what. You know that what x is, what theta is, and what vi is, then you're good to go. G is a constant. It's always this. This is all you'll be plugging this number 9.81 into your calculator all 5 of the homework problems. All right. So this is the deal. And so really the bulk of what I want to talk about is making sure that you know how to use your calculator with these three equations. And really, actually, if you are pretty decent in algebra, you can tell that actually all 3 of these equations are really equivalent to each other. They're the same thing. I just did the algebra for you so that like you could start with this top one, and if you wanted to solve for x, lo and behold, you get this guy. Or if you wanted to solve one of these guys for theta, you get this. And so, by the way, this little thing right here, we'll talk about a little bit. It's basically, you don't even necessarily need to understand what that means. You just have to understand that you'd have to know what button to push at this stage. If you've had enough trig, if you've had enough math, then it's no big deal. But if you don't understand what it is, you don't sweat it. You don't need to be able to do these problems. It'd be cooler if you did. And then backing it up a little bit, just to make sure you guys understand, speaking of knowing trig, this right here, this looks like a 0. It is not a 0. This is not sine of 20. This is not sine of 20. By the way, also, I guess I should back it up some more. Everybody, I hope, recognizes that this is sine. This is one of the trig things. If you've had geometry, you've seen it. And if not, like I was saying, it's okay. You just got to know what button to push. And we'll get to more, we'll use it a little bit more later in the year. And hopefully everybody is comfortable with what that means. But really, all in all, to be able to do these problems, you have to be able to plug in numbers and know how to use your calculator. So that's all this video is about, basically, is making sure you know how to do that. Okay, so here are 3 problems. Okay. They're really all actually the same scenario. It's the same scenario, only I've given you 2 things. You got to find the third thing. The unknown is switched each time. Okay, so you should know what the answer is going to be. Well, heck, right away. When we do this mumbo jumbo, we will get the 17.9 that's down here. This is just to make sure you know how to use your calculator, so I thought I'd give you ones where you're going to know what the answer is supposed to be after we do the first one. Actually, we already do. I told you it's 17.9. Alright, so here's how you use the calculator. Problem is there's generally a couple of different calculators you guys might have. I'll do the one, first I'll do it the way where if you see it as you type it in. Alright, so boom. So you see the square root. It's up here, if you notice. Alright. And then you you put parentheses, 9.81 times 21, and then you close the parentheses. Okay? That's the top of this fraction right here. Okay? 9.81 is always what g is. That's the acceleration due to gravity. And then x happens to be 21 meters. My policy on using units or writing units, if you're showing your work here, all right, and really I would I'll show you what I want to see, but you don't have to write units until the end. The units will be meters per second. This is, heck, I told you, this is the answer. 17.9 meters per second is what we're going to have. Divided by the sine, and you might as well just multiply it. So 2 times 20 is 40. So you don't need to put 2 times so-and-so. It'll always be something I think in general it'll work out pretty well. So if you notice that this looks kind of like this. And so then we just hit enter, and I hope it works out. Boom, 17.9. So this equals, let me show you what work I want you to see. This equals, oops, let's see, I had to edit there because I screwed up. Equals 9.81. Alright, let me back up because that looks ridiculous. Okay, it equals square root 9.81 times 21 over sine of 40. Okay. Oh my goodness. Hopefully your handwriting is better than that. And that's enough. You can just show that. Okay, notice you don't have to put units. I don't really care. And then you put the 17.9. Now don't say I don't care about units. I don't care about units until right here. Meters per second squared. Okay, use the units in the answer. I guess I always want to see degree symbol here. That's kind of bad form to not put that in there. But ignoring the handwriting, that's what I want to see. Okay? Similar deal down here. Let me do the second example. Clear that out. Okay, so I'll actually write it out first and then do the calculator. So let's say it's a similar, it really is ultimately the same scenario. I'm just saying, let's pretend I don't know how far it goes. All right? So I know how far it's shot, or how quickly it's shot. That's this right here, 17.9. I know what angle it was shot at. I want to know how far it's likely to go, assuming we don't have air resistance. That's too big of a deal, which is kind of shenanigans. But when you take into account air resistance, magically the math becomes much, much harder, and it's not really for high school. But anyway, so you do 7, hold on, 17.9 squared sine 40 over 9.81. Okay. And then, so let's go over here. Use 17, oops, squared. It's a good idea to put parentheses around numbers when you square it, but that's only really because if the number is negative, students tend to screw that up, but this is positive. And then we do sine, and then that's wrong. Let me back it up. 17. Okay, so times sine of 40. Okay, so it's the 2 times 20 is why I'm having 40. So 20 is over here. Theta is 20, so 2 times 20 is 40. And then actually I screwed up. No, I didn't. Never mind. Divided by 9.81. And there's the 20.99. Now it's not 20.1, or excuse me, yeah, 20.1, like from up here. Well, because this answer that I plugged in is rounded off. This wasn't exactly 17.9. It's close enough. Okay, illustrates the point. 20.9. It's 20.1 to the nearest number of significant figures, if you want to be careful about that, with which really should be. So it's 20 point. Whoa, not 20.1. Like I was saying, not 20.1, 21. And then units are meters. Okay. If the units are not meters, if it's a different unit of measurement, then this constant I'm putting in here, it's not 9.81. That's unique for meters and seconds. If it was different distance unit, then it would be 9.1. Alright, so last but not least, and this one is probably the most important because some of you might not be familiar with this thing right here, the -1 exponent. Well, it's not really an exponent, but it looks like one. So how do you do this? So it's, well, I'll just put 0.5 because that's 1/2. Okay, and then it's second and then sine. And I screwed up again like I did the same way. So it's 0.5 or times, and then you got to do inverse sine. There's 2 different ways to write this thing here, the sine with a little -1, and this is the other one, so I kind of chose a bad calculator. But I mean, whatever. It's either one. They mean the same thing. So this is sine with the -1, and then you have to do the 9.81 times 21 divided by looking for the squared. Boom. Okay. We kind of type it in. If you have one of those that you type it in as you see it, that's what I'm going to do here, is help you. If you have one of those, I'm going to do this with you, and if you have a different type, then I can help you one-on-one in class, I guess, because the video's already gotten a lot longer than I wanted it to be. All right, so you hit enter. Boom, there you go, it's 20. So equals 20. So I'm not going to even write it out. I'll just write the answer in here real quick, because I still wanted to do one last thing. 20 degrees. Okay. That's supposed to be degree symbol. Last but not least, distance formula. So this is the distance formula. So if you need to see an example of using the distance formula, maybe I need to help in class, because I think the video's already gotten a little bit too long here. So basically what it boils down to, if you have an aerial view, so if you're looking at this picture from above, okay, where did the picture go? So it's an aerial view to this projectile motion situation. By the way, trajectory was the word of the day, so it's awfully convenient. Okay. But here's your trajectory, kind of, from an aerial view here. And the coordinates are here and here. So in math class, you may have seen how to use the distance formula. Okay. Basically how it works is that, let's say you have the distance formula, the coordinates of 2 points. Basically, that's telling you how to figure out x. Okay, this distance right here is x, and how you figure that out is, well, this equals x. All right, so x without a little 1 or a 2 in front of it. Okay, or by it. It's called subscript, is what these little guys are underneath the x and the y. But anyway, that's how you figure it out. So just real quickly. 3, 4, and 7, 8. Let's see, is this that what I want? 4, and no, let's not do that. 7, 7. How about that? Okay, because that'll work out to be a nice whole number. I hope. Okay. So what you do is subtract the x's. And this is actually kind of better than slope, because it doesn't actually matter what order you subtract them in, because you're squaring them, and if that doesn't basically make sense, the idea is that in slope, if you get them in the wrong order, you're going to get the wrong sign. SIGN, not sign over here, trigonometry. It's going to be positive instead of negative, or vice versa. Here it doesn't matter because you're squaring it, it makes everything positive. And so this is 7 minus 4, so it's 4 squared plus 3 squared, okay, and that's this is 25, so it's the square root of 25, so it's 5 meters. Okay, so for the harder problems, they don't tell you x. You got to figure out x using the distance formula, and so there you go. Hopefully this was helpful. It seemed kind of rushed, and hopefully this helps you with the problems out of the 2 worksheets.